everyone, second method. So we are given function of x where e is raised to 0.3x minus e raised to negative 0.6x minus 2. We have x04, x13, and conduct two iterations, and we have a table here. F of x will be filling up shortly. So let us give the general formula of xi plus 1, which is equal to xi minus the function of xi times xi minus 1 times xi over f of xi minus function of xi minus 1. So let's get started. We substitute the value of our x1, which is 3, to e raised to 0.3 times 3 minus e raised to negative 0.6 times 3 minus 2, and we have a value of 1.2294. Our next is xi minus 1, so we substitute the 4, and we have an answer of 0.2943. So what we do next is that we substitute those functions on our general equation to have the x1 plus 1, and we have and we place those values on our table for our iteration 1. And then we simply compute for our approximation error, which is 11.72%. Going for the iteration number 2, we have function of xi equals e raised to 0.3 times 2.6853 minus e raised to negative 0.6 times 26853 minus 2. We have 0.0384. And we substitute those values again on our general formula. And we compute for the value, which is 2.6381, and we write that down on our table. And then we compute for the approximation error for our iteration number 2, and we have an approximation error of 1.78%. And that is very fast, because from 11.72% we have dropped to 1.78%, and we are close to 0%.